welcome today to this presentation. My name is Saša Stamenković, and I'm in front of OneSpin Seamless Business. And today I will be talking about a processor verification, and I will be mainly focusing to the RISC-V application. Before I deep dive into the details of the RISC-V, I'll just glimpse over the different solutions that OneSpin offers to their customers. First of all, when you see on the left is the functional correctness. That we have the tools to verify whether intended and implemented functionality are met. What this means is to verify whether the RTL works properly or System C design, or that, for example, two different implementations of the same designs are equivalent. So, for example, you have a netlist and an ECO has been done manually, then the tool has the capability to do that for you. In the middle, what you will see is the safety solutions. So what these tools are helping customers to do is to verify whether any faults can be caught by the design properly and whether they will be handled properly as well. So, for example, if you have a design in the field and there is a alpha particle hitting somewhere in the space, our tools can help you to identify how will that affect the functionality of the design. And finally, in terms of trust and security, we have solutions to verify any malicious data being injected, or that any negative effects can happen, like data leakages, etc. And the rest of the presentation, I will only focus on the RISC-V. So that's just a glimpse overview of what we are talking about. So what we have seen in yesterday and we'll see in the next 2 days is some of the challenges that we are facing when not only developing and verifying a RISC-V design, but in general a processor. So creating a processor is not easy. Not many companies do that at the end of the day. And what are the challenges with the RISC-V? It gives an extra capability of adding custom instructions. So sometimes that is not easy and often is not correct. The way we intended to do it and the way we did it is not really the right way it was done. So in terms of the verification, available solutions are mostly simulation-based or late in the board phase. So what OneSpin brings on the table, here are some of the benefits for using OneSpin solution. We have seen by using this solution, by applying it on different designs, is up to 10 times verification speed up. So that was one of the benefits because this solution is automated. I will deep dive into this a little bit. And very important, it's formal-based and gives you one of the other unique capabilities of OneSpin is 100% functional verification. So let me tell you a few words about the technology itself. So what's going on under the hood in this app? So if you look into this picture, starting from the bottom to the top, first it talks about the automation. So the app, the solution comes with the ISA model based for your RISC-V that you can set up and run by your own. So the tool automatically can analyze your design and, for example, extract the microarchitecture information and generate assertions, and finally give you a capability of running these assertions in the GUI or in the shell. And finally, we always need to debug something, right? So we have that capability as well. So how do you run this app? So this is the flowchart of how to use and run it. So you start from your core RTL, that's what's here at the very top. And as soon as you read the RTL, the tool will analyze it and extract a lot of information like microarchitecture information. Then, since we have a capability, as mentioned earlier, to add custom instructions or additional implementation information, we give that to the tool, and the tool further processes the design and information given, and out of it generates the assertion. So that's what you see in the very middle, this assertion generation procedure. And from that, you run assertions, hopefully not debug anything, what you see on the left side, and you go into the sign-off. So I'll talk a little bit about the sign-off and what capabilities we have in the tool in this area. But before I do that, I will just show you one slide that really gives you an idea how to set up the app and run it yourself. So this slide is actually showing a screenshot from the tool, where once you read the RTL, the tool is capable of extracting a lot of information like marker architecture and what is the ISA, the specific instructions that you have implemented into the design. For example, for the floating point, if you have the design, that can be found. And finally, if you're adding some user-written instructions, that's something that you can give as information to the tool. I will show you an example of such an instruction in the next slide. And finally, once that all is put together, what you see in the top right, you have these generate files for verification. So that's, let me just move my mouse. Doesn't go over, okay. What will happen, the tool will extract and generate the properties that can be verified against the engines. So what I mentioned just a few seconds ago is adding custom instructions. So that's very important for the RISC-V. And this is based on the SAIL language that's commonly used in the ISA for the RISC-V. So what you see is in this table is exactly the information that you are giving to the OneSpin verification app. So you start with the name of the instruction, you give it a decoding, what is the execution that this will do, and some restrictions if you may have for the specific instruction. And what OneSpin does is actually generating the assertions from this information given that you would verify, or the app would verify for you exhaustively. Then I will talk a little bit about the functional coverage, but what you can do with this set of the instructions that you have verified, that's one of the unique capabilities because nobody really uses formal only, right? We use simulation as well. So what OneSpin has developed over the years is the integration with the coverage results across the board of all the simulators available. So whatever your favorite simulator is, the results that you get from OneSpin, you can export those results into the favorite database that is in your simulator, and you can increase the coverage by running formal and moving on with simulation in the later phase. So that's how you can nicely combine simulation and formal all together. And we've been working with the vendors to implement this flow and nicely support it, and our customers are successfully using it. As I've call it a joke earlier, we always have to debug something, right? Nothing is perfect, whether it's a setup, could be a setup, right, but can also be something in the design that we didn't implement as we wanted. So what OneSpin I showed you here in this slide is what the debugger looks like. So on the left-hand side, you have the assertion that was generated by the app itself. At the bottom is the waveform with all the relevant signals. And finally, you can do the debugging in the upper right corner. Basically, what is in the red, that's the cause of the failure. In a nutshell, the tool is pinpointing where the problem is coming from. And then you can trace that back into your RTL and see what's causing the failure. These assertions are automatically generated by the tool based on the instruction, based on the information given to the tool. Thanks for asking. And of course, some of the results. So this is the results that we have seen for one of the cores that we've been running. That's one of the open cores. Sorry if the picture is very small because the tool generates a lot of assertions and properties under the hood. But in short, what you get is in green, it's good. In red, it's bad. In the sense that follow the red and debug these assertions to see what's causing the failure and what's the reason of the failure, right? That's what has been seen in the previous slide. And then coming to the end, these are some of the issues that using this app we have reported to the community for different cores. So just different types of the issues that we have found, and I will just mention one. It was based on the Rocket core. So when we were running the Rocket core in-house, we have seen that an instruction has been added. That's what the tool flagged. Instruction is added, and this is not it was not documented. The register for that custom instruction was not set properly. And when we reported that back to the Rocket team, they said, yeah, it's just we didn't put it into documentation first thing, and we didn't set the status register for the custom instruction properly. Once that has been fixed, we were able to reach the full coverage in terms of functionality. And finally, what we offer is 10 times faster results that are a lot of automation is in there that extracts information from the design. And very important, you get exhaustive coverage because one of the unique capabilities of OneSpin is that we have 100% functional coverage. So that's one of the big things that we have in our tools. And finally, those results that you got from formal can be combined with the simulation. So I hope I didn't exceed my 10 minutes. So you can find us on the other side of the Siemens booth. If you have any more questions, I'll be around for another hour, or you can find us downstairs for additional questions or maybe a demo about the app itself. Thank you. Thanks.